Hello guys, welcome to this tutorial. We are looking at thermodynamics today. Alright, so in this particular question we are required to find the change in entropy as a gas undergoes isothermal expansion. Alright, so the amount of heat that is supplied to the system actually gives us a constant temperature there. Okay, so now to find the change in entropy, we know that it's given us change in entropy equals the work done by a gas undergoing isothermal expansion at a constant temperature. Okay, so now what we need to know also is this work that is done by a gas is expressed as nRT natural log of V2 over V1, right? So where V2 is the final volume after the expansion and V1 was our initial volume. Okay, so notice also here that this same work is actually equivalent to the amount of heat that we supply to the system to maintain the internal energy of the system. All right, implying that the work is equal to the heat required, which is still nRT, the natural log of V2 V1. All right, so we can see here that if we write the expression for the change of entropy, it is the same as writing the change of entropy as Q over T, okay, where our Q is actually our expression for the work done. Okay, so if we substitute this into the change of entropy, we're going to have change in entropy being equal to nRT natural log of V2 over V1 divided by the temperature. Okay, so now that we have this, we can simply take out the temperature. Okay, and also we should notice that V2 is 3 times V1, okay, implying that V2 over V1 is the same as 3 V1 over V1, which is the same as 3. Okay, so we are going to remain with the change of entropy expressed as nR natural log of 3. Okay, so it has now been simplified. As you can see, we have actually expressed the V2 over V1 as a 3 here. Okay, so after doing this, the other thing we need to take note of is the number of moles here. Okay, so in the particular question that we have, we are told that rather we are given the mass as well as the molar mass of this gas. Okay, so we can use that to express, or rather find, the number of moles. And we know here that the number of moles, which is n, is usually given as the mass over the molar mass. All right, so we can actually substitute this expression for our n. Okay, meaning that the change in entropy now becomes mass over the molar mass times R and the natural log of 3. Right, so these values are given. The mass is given as 2 grams, which when expressed in kilograms is giving us 2 times 10 to the minus 3. Okay, so we are going to have 2 times 10 to the minus 3 kgs over 28 kgs per kilomole, all right, multiplied by the gas constant also. The gas constant is 8314 joules per K mole and Kelvin, right, times the natural log of 3. Okay, so now that we have this, we can go ahead and punch on our calculators, and we should be able to actually obtain the change in entropy after doing that with the units of joules per Kelvin, right? So I'm going to leave this step for you. Just punch on your calculator and actually obtain that value for the change in entropy. All right.